My apologies, everyone. I was trying to squeeze everything into just one video, 15 minutes for you, but unfortunately I wasn't able to do that, so you get another video of me. The software that I'm using is actually really cool. It allows you to record your screen and everything, but the downside is you can only record 15 minutes of video at a time, unless you upgrade for I think it's $1.65 a month, and then you can get longer videos. So I'm not going to be spending $1.65 a month, please. Unless you guys want to start a GoFundMe page, you can go ahead and raise that $1.65 for me, and then I can give you continuously streaming videos for longer than 15 minutes. So let's get back at it, back with finding X-intercepts of quadratic functions. So this one's going to have one little wrinkle to it. So again, to find the X-intercept of a quadratic, you're just going to change the y to a 0. So we get 3/4 x minus 7 squared plus 5. So first step, just set the y-coordinate to a 0. Then we're going to get rid of this plus 5. So we're going to subtract 5 from both sides. So we get minus 5 equals 3/4 times x minus 7 squared. I'm going to pause here. Please don't actually make a GoFundMe page for $1.65 a month. That would be kind of humiliating for me. So scratch that. To solve next, there's a couple ways that you could approach this. You could take the 3/4 and you could turn that into a decimal, 0.75, and you could just divide by 0.75 on both sides. I like dealing with the fractions, so what I'm going to do first is I'm going to multiply by 4 on both sides. And that will make the 4 on top and bottom cancel out. So on the left side, we now have negative 20 equals 3 times x minus 7 squared. The next thing to get rid of is that 3. So we're going to go ahead and divide by 3, and we get negative 20/3 equals x minus 7 squared. I'll rewrite that one. Negative 20/3 equals x minus 7 squared. And now to solve, we have to square root both sides. So if we square root, there should be alarm bells ringing in your head right now. If you try and take the square root of any negative number, it's not going to work. Go ahead and go on a calculator if you want. But if you try and take the square root of a negative, it becomes an error. The reason is a number times itself will always equal a positive number. It can never equal a negative number. So this, you run into an error. And what that means in the context of this is there will be no X-intercepts. And I'll explain that in just a second. So no X-intercepts for this one. And the reason being, let's take a look at that function that we just had. The vertex we can identify right now is at 7, 5. So we'll go ahead and draw somewhere around 7, 5 would maybe be about there. And then the A value is 3/4, which means it's going to open upwards. It would look something like this. And you will notice that that graph will never, ever, ever reach this value down here at the x-axis. So there are no x-intercepts. Some of you may have learned last year something about imaginary numbers. So there is a numerical way that you can find a number for those x-intercepts. It's just they aren't going to show up on the graph. So we're not going to deal with imaginary numbers right now. And on to the axis of symmetry. So this is going to be the one last component of a parabola that I haven't really talked about yet, and we'll formally introduce it. It's the axis of symmetry. It's probably one of the easiest ones to find. So if you imagine you have a quadratic function given by that function right there, and we know that the vertex is -4, -8. The axis of symmetry is just the equation of this dotted line that's going straight up through the middle of the graph. So before I get started, I'm going to show you a couple different types of graph that maybe we forgot. Let's say you have the graph y equals -3. A graph of y equals a number will just be a horizontal line going straight across. If I have the graph of x equals 1, it's going to be a vertical line going straight up and down at 1. So in this case, we have a vertical line, and that vertical line is right at -4. So the axis of symmetry in this case would be x equals -4. So it's a vertical line going up and down at -4. And you'll realize the axis of symmetry is just the x-coordinate of the vertex. That's it. So let's go ahead and do one more. Identify the axis of symmetry for this quadratic function. Let's just go ahead and try and visualize it first. I like to visualize things. Pretend that this is 100. Pretend that this is also 100. So our vertex would be at 75, 90. So we go over to 75 would be about there. 90 would be way up there. There's your vertex at 75, 90. Because the a value is -3, it's going to open downwards. Probably not to scale very much, but oh well. And the axis of symmetry is going to be this dotted line right here, which happened to be right at 75. So your axis of symmetry is x equals 75. Again, it is the x-coordinate of the vertex. Your vertex was 75, 90, and there is where your axis of symmetry is located, at 75. I'm going to go ahead and give you a chance to try and put it all together on your own. So this includes things from the last lesson that we had along with this lesson. So go ahead and pause the video, and I will go ahead and reveal the results when you are done. Okay. If you did this one correctly, you should have had a final equation of -2.5 for your a value. It should have been x minus 8 squared and plus 40. So hopefully you knew your vertex, and then you used this point to go ahead and solve for your a value of -2.5. Hopefully you also put a squared up there. Please don't forget that squared. For the next one where it says show that the y-intercept is -120, just plug in a 0 for x. It should evaluate to -120 if you did it correctly. To find the x-intercepts, you should have set the x equal to 0, and you would have found x-intercepts of 4 and 12. And the axis of symmetry, all you have to do there is look at the vertex. Since the vertex was at 840, your axis of symmetry is going to be at 8. So it's x equals 8 for your axis of symmetry. So hopefully you're all super excited about all the wonderful things you've learned about vertex form. Starting next, we will end up converting from vertex form into the one that you're probably most used to seeing, standard form. So we'll see you next time.